All right, happy Thursday. On the screen is the directions for today's lesson. You're going to need your warm-up, your notebook, and a calculator, preferably the Desmos calculator. Again, I put about how long each section should take you, so the warm-up should not take you any longer than 10 minutes. The notes and the examples, about 20 to 25 minutes, depending on how often you need to pause and rewind. And then the Bitly assignment, again, should take you about 20-25 minutes. So at this point, I would take the next about 6 or 7 minutes and do your warm up. So pause the video at this time, and then when you're ready to go over your warm up, unpause the video and see how you did. Remember, if you have any questions, make sure you're asking for help. All right, here we go with the warm up. So number one says that a painter is able to complete 1/4 of a wall in 1/8 of an hour. So that first sentence gave us our ratio and our ticket. We will be comparing walls and hours in this problem. The two numbers that needed to get stacked were 1/4 and 1/8 because those are the same numbers in the same sentence, so I always start there. The number 3 hours is in a sentence all by itself, so I plug that in on the bottom since I had hours on the bottom, and I'm going to put an X on top. From there, I'm going to cross multiply 1/8 times X. Remember, my calculator won't help me with that. And then when I do 1/4 times 3, remember, calculator's default is to give it to you as a fraction, or sorry, as a decimal. So we want fractions. So I'm going to put in 3/4. Make sure I'm scrolling to the right. Times 3. Oh, sorry, I put 3/4 instead of 1/4. 3/4, 1/4 times 3. Look, see how it gives us a decimal. Remember, we want to change that, so we want to convert that to 3/4. If the problem has fractions, we use fractions. If the problem has decimals, we use decimals. From there, I still have to isolate x by dividing each side by 1/8. So I'm going to take my answer, and I'm going to divide it by 1/8. And notice how my calculator gives me a whole number answer, not 24/4. So if you got 24/4, that's great. But remember, on NeoG, if it's calculator active, we need to make sure our answer is in simplest terms. So you should have got 6 for number 1. Number 2, our discount question today. John went to the store to buy a Nintendo Switch. The original price was $300. He has a 15% off coupon, and they want to know how much it was after the coupon. So the first thing I wanted to find was how much was that coupon worth? Well, it was 15% of the $300, means that they're going to take $45 off that Nintendo Switch. But again, since the problem wanted to know the final price I would pay after the coupon, I'm going to take the original price, subtract the $45 discount coupon, and end up with a final price of $255. Moving on to number 3. First thing I wanted to do was take a look at the problem. I have some parentheses, so I know I was going to over under in the first part of this problem. The negative 4x and the positive 10 were outside the parentheses and not touching the parentheses, meaning they got dropped down. So I did negative 3 times 2x and got negative 6x. I did negative 3 times positive 6 and got negative 18. And then again, all I did was drop down my negative 4x and drop down my positive 10. Then I went over to my Desmos calculator and I did negative 6 minus 4, and that gave me negative 10x. And then I did negative 18 plus 10 to give me negative 8. You could have also gotten negative 8 minus 10x. They're both equivalent answers, so that would be just fine. So remember, we over under to stuff inside the parentheses. Anything outside the parentheses gets dropped down and then combined if possible. And then the last one, number 4. First thing I did was looked at my two shapes. I know that I have a rectangle and a half circle or a semicircle. It wants to know the total area, so I had my two formulas. The very first thing I did in this problem was wrote down both formulas I would need. Area equals length times width for rectangles, and pi r squared divided by 2 for a semicircle. I went over and looked at my dimensions. I had 6 and 9 as my dimensions, so I did the length times the width. 6 times 9 is 54. And then I looked over here, this line that I'm going to highlight in green, this was the diameter of the semicircle. So again, I'm not going to use that diameter because I'm doing area. So I wanted the radius of 3, half as big. So I did pi 3 to the second power, all divided by 2, and I got half the area to be 14. But since it wants the total area, I have to combine the two shapes' areas. So 54 plus 14, I did it over here in green, and got a final answer of 68. So at this point, make sure your warm-up's all complete and you have all the good answers on there, and get ready to take some notes in your notebook. So to start off today, all I want you to do is take about 30 seconds or so and read these two problems in your head. I want you to say the operation. So don't say negative 5x over here. Think about what the relationship between negative 5 and x is. Is it being multiplied? Is it being subtracted? Is it being added? Is it being divided? The step to being good at what we're working on this week and next week is being able to read math and then do the inverse or opposite of what we talked about, just like yesterday. So I would pause the video and take about 30 seconds to a minute, read these two problems, think about if they're going to have the same answer or not. All right, here we go with this. So this first one on the left, we would read this as negative 5 plus x is equal to negative 25. Well, again, yesterday we talked about breaking it into two sides, the left side and the right side through the equal sign, and locating our variable. What's being done by that variable? Well, it's being combined with a negative 5. And yesterday we talked about the opposite of minus or negative being adding. So this problem, we're going to add 10. Oh, not add 10, sorry, add 5. I don't know where I got the 10 from. We're going to add 5 to get rid of the negative 5. And whatever I do to one side, I do the same thing to the other. And then I would go in my Desmos calculator, negative 25 plus 5 is going to be negative 20. This one, I'm going to read it, but I'm going to show you how to solve this one on the next slide. So this would be read as negative 5 times x is equal to or the same as negative 25. Remember, when we have a number and a variable stuck together, when we have a coefficient and a variable stuck together, that always means multiplication. So these are going to be the problems on the right that we're going to work on today. Today we're going to do the opposite of what we did yesterday. Instead of adding and subtracting, we're going to be multiplying and dividing, again, using the calculator. So if you haven't already, put this example into your notebook. So again, this is how we read it. Negative 5 times x is the same as or equal to 25. Since I said that I'm going to be doing negative 5 times x, the inverse operation of that is to divide each side by negative 5. So again, I divided the left side and the right side both by the coefficient negative 5. Negative 5 divided by negative 5 is 1. So we get 1x. And remember, our final goal yesterday was to get x by itself. And then whatever I do to one side, I do to the other. So 25 divided by negative 5 is negative 5. And that's the answer. So make sure you have this one into your notes. I'm going to do one more example, and then you're going to try a couple on your own. Okay, so this is going to be the one. I'm going to do this top example with you, and then I'll tell you how much time it should take you to do the bottom one on your own. So again, write down 8 times x is equal to negative 24. Again, yesterday we talked about breaking it into a left side, right side. We find the middle of the problem, that's the equal sign. We locate where the variable is by putting a box or a circle around it. Here I have 8 times x. I said times 8, so I know that the inverse or opposite of multiplying by 8 is to divide by 8. Again, whatever I do to one side, I've got to do to the other. One side goes away because 8 divided by 8 is 1x. And then we have negative 24 divided by 8, which in a calculator would say negative 3. Okay, so I want you to use that example. It should take you about 3 minutes to do these next two problems. So I'm not going to start the timer like I did yesterday, but keep an eye on your time. Take about 3 minutes, solve these two, and when you're ready, unpause the video, and I'll go over those two with you. All right, here we go with those two. So the first one, we would read that as negative 12 times x is equal to negative 60. So my variable's on the left side. What's being done to that variable? It's being multiplied by negative 12. The opposite is to divide each side by negative 12. Again, the negative 12s will go away. Our goal is to get x on one side by itself, which we would there. And then negative 60 divided by negative 12 is positive 5. So you should have gotten x is equal to 5. And then the second one down below, we have 81 is equal to negative 9 times x. Remember, it doesn't matter what side the variable's on. We always do the inverse or opposite operation to the variable side. That's why we locate where the variable is with a box or a circle. Again, what's being done to x? It's being multiplied by negative 9. The opposite of multiplying by negative 9 would be to divide each side by negative 9. Again, the negative 9s will cancel out and leave us with 1x. And then in my calculator, I would do 81 divided by negative 9, and my calculator would read negative 9. All right, so like I said, we were working on multiplication and division problems. Well, here's solving division problems. So go ahead and put this example. I got 2 examples and then same thing, a couple for you to try. So this is not a fraction. We don't read this as n over 6 is equal to negative 12. We read this as n divided by 6 is equal to negative 12. So remember, it's very rare that you're going to see your division signs like you used to. Now you're going to start seeing them as fraction bars, whether they're something over something or something over something like that on my screen. Okay, so again, what do I have to do to get n by itself? Well, let's find out where n is, right here on the left side. What is being done to n? It's being divided by 6. I know that the opposite of dividing by 6 is going to be to multiply by 6. So I'm going to multiply the left side by 6 to get rid of the 6, and then whatever I do to one side to get rid of the numbers and get the variable by itself, I do the same thing to the other side. And then in my calculator, I would have done negative 12 times 6, and you would have gotten negative 72 as your final answer. Okay, and one more example before I have you try some on your own. Again, I have the answer there, but how did I get 50? Well, I broke the problem into a left side, right side. I located where my variable was. This problem would be x divided by negative 5. I know the inverse operation or opposite of dividing by negative 5 is to multiply by negative 5. And again, whatever I do to one side to get rid of the numbers and get the variable by itself, I do the same thing to the other side. And then in my calculator, negative 10 multiplied by negative 5 would be positive 50. So again, make sure you have those 2 examples into your notes, and then I'm going to have you try 2 on this next slide, or 3, sorry. So you're going to try these 3 problems. I would take about 4 minutes, but if it takes you less time and you need to unpause the video sooner, by all means. But it should not take you more than 4 minutes to solve these 3 problems using the strategies that I just showed you. So pause the video at this time. Try these 3 problems out, and when you're ready, unpause it, and I'll go over them with you. All right, here we go with those 3 problems. So I'm going to break them down one at a time here. The first problem, which was on the left, was x divided by 4 is equal to negative 12. Again, I said x divided by 4, so the opposite of dividing by 4 would be to multiply by 4 to get rid of the 4. And then negative 12 times 4 is negative 36. So you should have gotten x is equal to negative 36 for that first one. The problem that was in the middle, I have right here. So we have negative 3 is equal to m divided by 8. I said that m was being divided by 8, so I needed to multiply each side by 8 to get rid of that 8 and to get m by itself. And then 8 times negative 3 would be negative 24. And then the final one, the one that was on the right, we have n divided by 1.5 is equal to 12. Again, it doesn't matter if we're dealing with fractions, decimals, whole numbers, the process it remains the same. I have n divided by 1.5. The opposite or inverse of that would be to multiply each side by 1.5, and then 12 times 1.5 is 18. So you should have gotten n is equal to 18. So today's assignment is the bit.ly that is on my screen. Tomorrow we will be taking a quiz. It will involve the warm-up questions, combining and distributing what we did last week and on Tuesday of this week, and then the last 2 days with one-step equations. Remember, if you have good notes and everything, you can use those notes on tomorrow's quiz. And if you have any questions while you're working on the bit.ly, make sure that you raise your hand and you get some help.